DevOps. Auf die Ohren und ins Hirn. Ein Podcast rund um DevOps.
Von Luca Ingianni
und Dirk Söllner.
Welcome to a new episode of DevOps auf die Ohren und ins Hirn, or in English, DevOps from your ears straight to your brain. Usually this is a German language podcast, but sometimes we make exceptions for international guests. Today is one such exception. My name is Luca Ingianni. I'm a DevOps consultant, trainer, and coach, trying to get teams to work together better and create better products for their customers. And I host this podcast together with my colleague Dirk Söllner, who unfortunately couldn't make it today. Today, I have the pleasure to introduce my friend Paul Swail. He's a solo consultant who specializes in serverless. We've had a German language serverless episode before, episode 26. I'll link to it in the show notes. But while that episode was fairly technical, I wanted to talk to Paul about the higher level challenges, the architectural and organizational issues you might face when moving to serverless. So, hi, Paul. Thanks a lot for being on our show today.
Hey, Luca. Thanks a lot for having me. It's great to be here.
So, tell us a little bit about yourself, Paul.
Well, as you said, I'm a serverless consultant. I'm based in Belfast in Ireland. I've been independent for almost 10 years. For 20 years, I've been working in software professionally as an architect and software engineer. Independent for about 9 of those years. And the last 3 years, I decided to specialize in serverless. I had been doing some general sort of cloud work, working with Node.js on AWS, sort of container based, and then I sort of decided I sort of seen serverless was sort of the way things are going generally in software development, and decided to specialize in that area. Yeah, about 3 years ago now.
Mm-hmm. So you said you saw that serverless was the way things were going. Can you elaborate on that a little bit?
Yeah, I guess it's sort of related to my whole sort of developer journey or my career. Everything, I guess, as a developer, everything you want to do things faster with a higher quality, sort of productivity based. A lot of the things around serverless is using sort of hosted services and effectively not doing things that you've always thought you had to do, like installing patches on servers, which is the obvious thing which serverless gets around, and you can just pretty much focus on building apps. I sort of focus more on the back end nowadays, but I used to do like full stack front end, back end web development, and just being able to use services which just do these things that you do for every single project. Just not having to do those is a really big benefit, and just being able to hand that off to a cloud provider who will do that for you, will do part of that for you. It just allows you and the rest of the developers on your team to be able to focus on just the actual business requirements and just building out what they call the non-undifferentiated heavy lifting.
Mm-hmm. Yeah, but let's be honest, serverless still means somebody's got a server somewhere, right? So who's taking care of that server?
Yes, that's the whole. Yeah, it's a terrible name. Let's get that bit out of the way at the start. It is. It's a can of worms when you talk about the name. Technically, yes, there are absolutely servers there. It all runs on some sort of Amazon's or Google's servers. So the obvious like AWS Lambda functions as a service, they run on a server. The serverless. The word means that you don't need to think about the server that it's running on. It doesn't mean that it doesn't exist, but it means that you as the developer or the architect designing the system don't need to care. You can treat a function as your lowest level building block that you can build your applications, and that you don't really care about like what operating system or anything like that.
Okay, I see. Something you just said I found interesting, which is you said, oh, you don't really have to worry about servers and patching them and that sort of thing. And then you sort of qualified that and said, yeah, well, not usually anyway. What do you mean by that?
You definitely don't need to. I wasn't qualifying that you don't need to worry about patching servers. That is something which has gone away. If you're building a fully serverless application now, there are plenty of hybrid type service applications where you still would need to do that partly, but that's not really what I'm getting at. And there's still lots of things that won't go away. So like your package management. So if you're running like Node.js is probably the most popular, along with Python, the most popular Lambda, the AWS Lambda languages to use. Like you still would need to worry about like your npm packages and keeping them up to date. So there's absolutely things which are still things which you wouldn't consider value add to your business, to the business problem that you're working on, which you still need to do. So it's not a panacea that solves everything for you, but it one of the key things that I've noticed in the teams that I work in, the teams are smaller, so you need individual developers can take on more ownership of more what you would call infrastructure parts of the system, whereas in the past with sort of more traditional server-based systems, you really need dedicated people because for those jobs, because there is a lot more to them. So like getting network configuration all set up and make sure all ports are locked down, all those sort of concerns. Having a front end or a full stack web developer handle all those things can be very risky. Whereas that role goes away if you have a serverless focused development team. You don't need that dedicated network sort of systems engineer person on your team. You can get away with a smaller sort of set of application-based developers, and that just bubbles it up to the business level. The people who are actually, the whole point of building the software in the first place is the business value that it's generating, and effectively, no engineers don't like to be seen as a cost, but the further lower down the stack you are, the more the business would see you as a cost. Mm-hmm. Whereas I always envied the front end developers in the teams that I would work in, like the designers, because they're getting all the great feedback from the clients, and that looks great. That's exactly the way we look at it, and that's like, while technically, it probably isn't that difficult what they've done, but it's the real value is being delivered there to the end user. Whereas nobody really cares what servers, they don't care what servers or what Kubernetes stack your app's built on top of, as long as it's up and it's doing what it's supposed to be doing and it's doing that well. That's where the real value is.
Interesting. So yeah, serverless, if I understand this right, is really just a way of the entire team being able to focus on customer value, and all of the things that are not really a value add gets dealt with by the AWSs or the Googles of the world.
Exactly. Yes, and there are other smaller vendors sort of layering even on top of that. So AWS have their sort of like the likes of Lambda or DynamoDB, sort of like services that you don't need to do, that just sort of you can treat as an API effectively. And there's the likes of Netlify and Vercel, who are even a layer on top of that, adding extra developer experience things. So you like no config or minimal config, like automatic CI/CD, just almost out of the box. Lots of sort of layers on top of just moving up and up the stack.
Mm-hmm. But so what I'm wondering is, if we're contrasting that with maybe microservices or something, which are, can we say they are more traditional? Not sure. Maybe
I don't think they're comparable. Like you could build a serverless. You can build a serverless only microservices architecture. I don't think they're not one or the other. It's not either serverless or microservices. So I could say you could absolutely design it such that every microservice, I hate the term microservice because it implies small, whereas they're not necessarily small. Whatever the services are, they could be totally built in serverless only architectures and talk to each other, like say via an event bus. So it would tick all the boxes, the 12 points for the microservices. What do you call that? No, the 12. I can't remember. It's 12 boxes. You can say this is a microservices architecture. You could totally do that in serverless. So it's not one or the other. But if you're thinking the sort of more way microservices architectures have been built, either on VMs or on containers, it's definitely a higher level than that. So you don't need to worry about getting a fleet of VMs where you run all your containers on top of.
Mm-hmm.
But
Okay, so you don't need to worry about all of the deployment issues, really. I mean,
well,
you need to deploy your application code, but that's all there is.
Yeah, you absolutely could. Like, microservices has lots of pros and lots of cons. So if you think in terms of, let's look at the drawbacks around like the distributed logging, the distributed deployment. If you could absolutely get all those issues if you build your serverless app in a certain way. And some things like the distributed logging is somewhat of an issue. So you have different parts writing to different logs, and sort of like there are tools to sort of collate them, but you need to set those up. But the whole like having a single monolithic deployment of a serverless app, despite like the compute is inherently distributed, so there's no getting away from that. Everything, lots of Lambda functions, but you can deploy them all in a single package effectively. AWS provides a tool called CloudFormation, which is like an infrastructure as code for effectively deploying a single atomic set of resources in one go, so it will either deploy it or fail. So you can get around like microservices issues of having to deploy all these things separately by just effectively treating it as I call it a distributed monolith, which some people may think that sounds terrible, but taking the good aspect of the monolithic deployment with the good aspects of the and the scalability of the scalable of the distributed compute that Lambda gives you.
Mm-hmm. So you get the simplicity of thinking about a monolithic thing, but you get the infinite scalability of Lambdas.
Exactly. Yeah, that's the way I sort of. If you've got bigger teams, you could design your serverless app using microservices, but most of the teams that I've worked with, especially on a greenfield project at the start, I always start with like a monolithic deployment, so everything gets deployed together from the same single Git repository, deploying everything together, and you don't then need to reason about just partial deployments and partial rollbacks, and that's where microservices can get really confusing, especially for a small team. And going back to the whole having a team which needs less members, which can be sort of more application developer focused. If you start getting into really complex deployment scenarios, then you're sort of taking away the benefits of going down the serverless route in the first place. So keeping it simple, just deploying monolithically, but still using Lambdas, so that like Lambda gives you highly scalable compute. You don't need to worry about load balancing generally until you're hitting really large scale.
Okay, wonderful. You touched on a couple of interesting points there, and maybe we can spend a couple of minutes looking at that in more detail. Like,
yes, for sure.
The typical ways that I would ask you for like best practices or something, but can I ask you for worst practices instead? Like, what are guaranteed ways of messing up your serverless application?
Okay, let's see. So I guess one of the big, if you're coming to serverless for the first time, your tendency will be to, how do I get this working on my machine? And the answer normally is you don't. So you will get part of it, and there are emulators which you can use, but for some services, but they're either subpar or there's other issues with them. So I generally say don't. You can run like the Lambda body of the Lambda code on your own machine, but anything above that, it's like you need your own cloud environment. So trying to get everything running on your own machine and create AWS emulators, that's just don't even try, because they're just going to diverge from what works on your machine won't work in the cloud. That's just what's going to happen. So that's one area. Sort of more, it's not an absolute terrible thing to do, but it's becoming a best practice to generally keep your Lambda function small, preferably single purpose. So if you're, say you're building a REST API and you've got lots of different endpoints, like gets and posts, and for lots of different resources, there are ways you could effectively just build your whole app inside your whole REST API inside a single Lambda function. I'd say that's a bad idea for a couple of reasons. Number one, from a pure scalability point of view, if you've got one endpoint which is hitting a lot, it's going to, the way the Lambda will work, you could lose your concurrency very quickly. So different functions, you can throttle them at a certain level. So if there's something really heavily hit and you don't want it to have a knock-on effect on the rest of your application, you can throttle that specific function. So that's one sort of area. But just even from a monitoring point of view, being able to monitor individual Lambda functions is very powerful. So you can say have their own logs. Okay, this endpoint is getting lots of errors. Let's quickly find that. You just know what log file that is because every Lambda function has their own log file. And the likes of, and just from a code reasoning point of view, just seeing that specific endpoint, you would be doing it anyway. If you're building, like, say, Express.js web app, you would probably have your endpoint built as a JavaScript function. So this just takes that to the next level. It's just saying deploying that single code, that single JavaScript function effectively to your Lambda. And that has performance benefits because it's a lot smaller. The Lambda spins up a lot faster because it's just got the code for one function within it, not for the whole application.
Okay, so essentially having a Lambda which is like a giant main function with no functions sounds like a bad idea. Yeah, I get that.
Yeah. Let me see what other bad practices do we see? Infrastructure as code or not using it. Infrastructure as code. One of the good things with serverless framework is that serverless and the serverless framework, which is a specific tool that you can use for infrastructure as code, you're almost forced to define all your cloud resources within code. You could go into, say, the AWS console and point and click and create lots of things and deploy things like that. But you'll quickly find out that that's going to take, it's not going to be reproducible and it's going to take you a long time. It's just going to be very error prone. So some people still try to do that. And they soon get caught out once it comes to having someone else in their team. If it's a one-person team building a prototype, you could probably get away with it. But then prototypes always develop into something further, and then you're like, okay, we need to define all this in infrastructure as code. And yeah, there's a lot of reverse engineering to try and get what they created down into code. So I would say start with infrastructure as code from the get-go, from the very start. There are several tools out there, Serverless Framework, AWS SAM, which do these things for you. So use them.
Okay, so in a way, it sounds like as long as you use time-honored good practice, good software engineering practice, you're going to be okay, right?
In certain respects, yes, there are some evergreen best practices which are always going, no matter what architecture you're using, serverless or whatever. So keeping things simple, that's always, you aren't going to need it. Basic things like that, which, like, yeah, always stick to those. I guess, yeah, the main paradigm shift, I guess, is the whole non-local development. That is something which has been pervasive for developers pretty much as far as I can remember, since I've been a developer anyway. Like, you always had the idea, like, you always get your own development environment working on your own machine, and that's generally not the way you would do it. So I think that's the biggest difference. But yeah, other standard best practices that I mentioned generally, yeah, they still hold. So we're not throwing out everything that we've learned from the past.
So Does that mean that everything is suited for serverless? Like, could we just grab any random application and say, yeah, now we re-implemented this serverless? Or are there certain things that are maybe that just don't quite work that
Well,
well?
I'd never. I'm always like the whole migrating existing apps is a whole issue on its own. So there's lots of nuance specific to each case for existing apps. But let's say you have a new app idea, and you're saying, should I build this in serverless? What types of apps or workloads would not be a good fit? Now, this is a question which it's a bit of a moving target. So if you'd asked me this 2 years ago, this list would have been longer, but it's getting shorter as the cloud providers add features or add new services. So right now, I would say it's like a serverless first mindset. It's like whatever use cases you have, look for a serverless service which does this. If that doesn't exist, then use another option. But what are the reasons why you wouldn't? So I would say one of the current limits is on if you have a long running stateful task, like a process which needs to run over a long time, and it uses an existing app which mightn't have been designed for like a short running compute like Lambda. Lambda has a maximum execution time at the moment of 15 minutes. So if you have something which needs to run for longer than that, it's not a good use case. So an example, I was working on a client app and they've got an SEO crawler which needs to run. They've got an existing CLI task which crawls website, but that runs like it could take for hours for all the different links that it follows. So you couldn't really run that within a Lambda function. So that's a use case. If you need really low latency from an API, from a REST API, like you're talking like single milliseconds, there is a concept of cold starts, which were a big talking point or a big objection that people use in serverless when Lambda functions first came out. They're much less of an issue. Like cloud providers have mitigated those significantly, but there still is the very first time you've deployed a Lambda function, and it gets its first request, there is a small, what they call a cold start, to load it into memory and to do that. So there's some like financial transactions. So it's like doing computed stock market type apps. They would be a case where that wouldn't be, like Lambda based API wouldn't be a great fit. But that list is coming quite, like there aren't many types of new build greenfield applications, which I wouldn't say don't start initially with a serverless based approach. But actually one other thing, a couple of other types of databases I would say. So Neo4j graph databases and Elasticsearch are two ones that come to mind. They don't have at the moment like what you would call a fully serverless offering, a cloud. So you would need there are what they would call fully managed hosted offerings. Maybe just explain the difference, what I mean in a minute. But you still need to do some upfront capacity planning for the types of database you would need for those. And you still need to capacity plan for your peak load, not for your average load. Whereas with serverless, you don't really need to think about what your peak load is going to be as long as it's within the Lambda's concurrency limit. And you're not paying for peak load, you're only paying for exactly what you use. So those are the sort of main attributes you think about considering, is this service a serverless service? It's not easy to say.
Interesting. So yeah, it was interesting to watch you try and come up with things that don't lend themselves to serverless. It looks like you have to really struggle to find good examples of that.
Like say about a year ago, another item on that list was, so if you had a type of application which was containerized, like a service, like they used to get appliances in VMs, like a company would put their product in a VM, and then people would do that with a container as well, and used to say, right, okay, no, well, you couldn't do that in a serverless app, but now there are like Lambda supports container based deployments now as well. And there's a service called AWS Fargate, which is semi sort of in the hybrid world between containers and serverless, where you don't need to worry about the servers, but it runs a container on demand. It spins it up, runs it for the duration that it needs to run, and then it closes down. So yeah.
So let's imagine that I want to get started with serverless. And just to make it maybe a bit more exciting, let's say I have an existing application and I want to try something new.
Mm-hmm.
How should I do that in a way that doesn't end in tears?
Okay, so you know the requirements. Yeah. I'm going to put aside any discussions about whether it's the best use of your time to migrate an existing app, but assume it is.
Not migrating, but okay. I need some new functionality for this existing app. And so I figure I might as well, instead of creating another microservice or something, I try out this fancy new serverless thing.
Okay, that's good, because I did this exact thing. Like I have a separate sort of SaaS product business I've been running for about 7, 8, 9 years, which was container based. It's still going. It's quite small, but it was built based on containers. And then 3 or 4 years ago, I was getting into serverless. It's like, okay, a lot of the way I've architected this application would be a better fit for serverless. Most my monthly bill would be less as well, but the actual ongoing maintenance that I was doing on the servers would go away. So it used a elastic load balancer, which is like a load balancer. But what you can do is I was gradually taking new REST API endpoints that I was adding. So, and rather than adding them to my existing REST API container-based app, I was routing them to my Lambda functions. So you can intercept them, put what they call API gateway, which is an API service provided by AWS, and it just route certain requests which match a certain path, any of the new API endpoints that I was building. So rather than routing it to the old app, it routed it to my new serverless app, and then just started building out the new features, the new endpoints within Lambda. And gradually, I never completed the project, but parts of it is just it's a way of just extracting. You're saying, right, okay, you're not going to do a big bang crossover. You can't, because all the risk that would involve. You can take piece by piece, like endpoint by endpoint, where they're like within your REST API, say, you can just migrate them one at a time over to the new system. If you're getting into databases, it gets a bit more complicated, or keeping data in sync. But if it's purely like the compute part of your code, then there are definitely techniques for doing that. But if you didn't know anything about serverless at all, I guess where I usually recommend to people, if they want to just deploy their first serverless app, say a REST API. I keep using that example, but it's a well-known thing. Using the serverless framework, serverless.com, it has lots of good examples about quickly defining some endpoints, writing a simple JavaScript, Node.js Lambda function, and just getting a response, deploying it to the cloud, and getting your response back quickly.
Mm-hmm. Okay, so in essence, what you were describing is just a classic strangler pattern.
Exactly. That was the word. Exactly. The strangler pattern. I knew there was a pattern name, and it wasn't coming to me, so I just stumbled over it. Yes, that's exactly what it is. That's it.
Okay. Wonderful. And that works well. And I suppose that's really obvious if you think about it, just because, serverless, you can write a single Lambda function, you throw it at the cloud someplace, and that's it, isn't it?
Yeah.
Like, there's nothing else to do, really.
Yeah, and another good use case for getting started, sort of like I said, it's like a low-hanging fruit. If you're a developer in your organization who are maybe quite skeptical about serverless, and you can see the benefit of it, then say, okay, well, look at all these cron jobs that we have. Cron jobs are a good like low-hanging fruit, where you could say, okay, Lambda allows you to configure a cron schedule to run this custom compute on a schedule, so either a nightly job to send out email reports or something like that. Whatever it is, having this configure a server just for that would be a real pain. Just having to run those jobs. Plus, you end up doubling up on a server. You have like stuff which is serving front end API and it's also running back end jobs in a cron on the same server. And you're like, if it's a heavyweight processing job in the background, it could bring down the whole server. Whereas if you just implement that as a Lambda function, just run the code in the Lambda function on a simple configuration schedule and just deploy it, it just works for you in the cloud. You don't need it to, you don't need to worry about it bringing down a server or setting up a server in the first place for it.
Oh, that's interesting. That's such helpful advice, I think, because it's also such a, as you say, it's such a nice low-hanging fruit because it's fairly low risk. Like, yeah, you're porting a cron job or implementing a new cron job as a Lambda function, and if it doesn't quite work all that well, then maybe you don't run those emails for a night or something.
Yeah. The good thing with cron jobs are generally not user facing, so or the minimum user impact. So yeah, they're a good place to start.
Okay, wonderful. So now I'm all excited about this newfangled serverless thing. So, like, how can I safely grow my serverless portion of my application? Like, it's all well and good if it's like 5 lambdas and I can keep them in a head, no problem. But how do I sustainably build a serverless application? What do I need to do in order to keep it maintainable, testable, free from too much technical debt, that sort of thing?
Yeah. There's a few things there, and you alluded to it with the number of Lambda function. That's a criticism which people who haven't used serverless before often say, okay, but now I'm just going to end up with a load of Lambda functions to manage. But I would just say you from a pure code point of view, you have the exact same amount of code as you would have if that was in a monolithic deployment. They're just functions. Whether it's a code function on your file system or a Lambda function in the cloud, it's exact same amount of code from the code point of view. There's a little bit more configuration, I should say, like around you may configure a timeout for a Lambda function or just the path to the source. So there's like a couple of extra lines of YAML, I would say, but more or less the same amount of code that you would have normally. So your considerations then around growing as your application grows, it's the same as you would for any growing code base. You still like modularizing it, splitting it, keeping the sensible folder structures. If it comes to it, consider microservices if your team is starting to, if it's being worked on by multiple teams possibly, and you can sort of come up with potentially a contract for them to talk to each other. At that stage, you can sort of start splitting your serverless system out into microservices. But that's if it's getting quite big. What other? Yeah, on a monitoring sort of when you're in production, AWS has tools which are okay, I would say, for our operations team for basic stuff. But if you've got a more sort of advanced operational concern, like if you want sort of really fully single, really nice dashboards, all looking really nice, getting all the information in one place, there are third-party providers which sort of aggregate the data that AWS CloudWatch would collect, or it can plug in its own agents into your Lambda code and send your data, and you get all the nice dashboards and alarms. So that is something as your application grows and it's in production that you'll need to look into. But AWS CloudWatch, which is their sort of monitoring and logging service out of the box, it does a good enough job, I would say, to get you started anyway before you need to look at third parties. I think what else? Yeah, testability. You mentioned, yeah. So that again was in the middle of last year. I ran a survey. I have a newsletter and asked several people on LinkedIn to participate. So I think we've got over about 150 to 200 responses for people who have been building serverless apps or who've got started. Nice. Asking the questions really were around what were the main pain points. And the top two I mentioned, observability and monitoring. So that was number one. And number two was testing. So testing is an area which, again, there's a slight paradigm shift coming from other non-serverless based development. So we start, like I mentioned, the whole local remote thing, difference. That is an issue here from the standard. If you think back, if you know was it Martin Fowler, or I don't know who came up with the original testing pyramid, which has it's like a pyramid triangle shape with unit tests at the bottom, integration tests in the middle, and like end-to-end system tests, whatever you call them, at the top. And as it gets up, there are less of them. So the idea was that the vast majority of the tests in your system of automated tests would be unit tests, and then you would have some integration tests and even less end-to-end tests. That paradigm, in my experience and from talking to other serverless experts, that doesn't quite hold for serverless sort of cloud services based applications, because the risk now falls to the risk of is less code based, whereas unit tests are really focused on the code, the actual procedural code, whether it's Node.js or Java or Python, whatever you're writing your code in. That is seen as the biggest risk, the riskiest area that needs the most testing. Whereas in serverless apps, it's not quite, that isn't the case as much. Now you still do write unit tests, but the integration points between the services become the real things where the ball can be dropped, where configuration is wrong. A big thing in AWS land is IAM, so it's the access control, identity and access management. Yes, that's it. The serverless allows you to define, Lambda functions allow you to define really fine-grained permissions on each function, which is best practice, and you do that by default. But you can very easily, if you did try and run something on your own machine, it would just work because IAM isn't in play on your own machine. Whereas you would deploy it into the cloud and it would throw an error because it doesn't have sufficient IAM permissions to talk to DynamoDB, let's say. So that's writing integration tests or end-to-end tests, even that hit your actual REST API endpoint or your GraphQL API endpoint, to bottom out those issues to make sure that all the configuration that you've written is correct. So writing integration and end-to-end tests is much more important when you're building serverless apps.
Yeah, that's funny. It just occurred to me, like if I'm writing a normal like Java app, I don't need to prove that my function can call another function. It's just a given.
Yeah.
And all of a sudden, that's not quite the case anymore, is it?
Yeah. When you think of distributed systems, JavaScript, you can just assume, because they're very tightly coupled. They are, well, like a function, a code, Java function calls another one. You assume that, where you can't assume these services in the cloud, you're responsible for tying them together. You're effectively tying the knot. Your developers are tying the knot between them and making sure they're talking the right language and they have permissions to talk to each other. And that's all done by infrastructure as code. So you still need to write tests to verify that, because there are a lot more integration points between services and cloud resources.
Interesting. But another thing that worried me, as somebody who has never tried serverless before, is how would I be able to effectively debug something if I throw an input at some function and it maybe goes through a bunch of different lambdas until it finally reaches its destination, like a proper integration test. How can I easily debug where it breaks?
Yeah. So the scenario you talked about there, so multiple lambdas chained together. So AWS has this service, that sort of orchestration flow. I guess when you've multiple, I guess there's the choreography and orchestration, which I'm gonna, without getting too deep into the patterns, orchestration is when you have, like a sequence of actions, integration points between different services that you want to run in a certain sequence, or you may want to add some extra sort of logic. But there's a service called AWS Step Functions, which it's like a state machine. You define it in JSON or YAML and different states. For each state, you would say have a task, which would be implemented as a Lambda function. It has a nice visual in the console in the browser. It has a nice visual green or red. So if something fails, it will just highlight in red. You just click through to the red, and it will have the logs for that right beside it. So that step functions for like for an orchestrated workflow is very good at helping you debug what went wrong. I mentioned also what we call a choreography style sort of integrations, where each sort of piece, say you have like an order management service was the canonical example, where you have a website like Amazon.com where you place an order and it just publishes an event, say order created event, and then you have lots of other microservices which then consume that. They sort of pull or read the message off the bus and do their own thing, like delivery, shipping, or pricing. That they, just by the whole distributed nature, are generally harder to debug. So if something goes wrong, you need to check. You sort of at the point where you check all those points. Did the message get published in the first place? Okay. No. Okay. Then narrowing it down from there. Whereas, okay, is it a downstream service which just failed? Then you end up looking the logs for that specific service. So yeah, if you've got choreographed sort of workflows, they are, I would, generally the hardest to debug once they're live.
Mm-hmm. Okay, so no, just like stepping through a piece of your code or something. That's just not just not reasonably possible.
No, there is AWS CloudWatch logs, so it's where Lambda and other AWS services write their logs to. It does have say you have a transaction ID, which is the same value through all it passes through all, like the order service, your shipping service. You can filter on, say it's a UID. You can do a search within it. It's quite slow and limited, but there are other, if you were using a sort of richer logging aggregation service, that would probably be an easier way of doing it. So, but if you have what they call just that unique transaction ID or correlation ID, which correlates all the different messages for that single transaction across the different services, that really helps.
Okay. So I think now I feel quite confident that I can build my first serverless application. Is there something we've missed? Given that this episode is called Practical Serverless, I think we've been pretty thorough, haven't we?
Yeah, well, I guess I've probably been more back-end focused, so I'm talking a lot about Lambda functions. That's more about my recent experience in the last couple of years, but there are, I guess, going back to the whole mindset of serverless and encouraging bringing development up the stack and closer to the end user. So if you're thinking about empowering, I sort of like to think eventually not front-end developers, but people who build the front end can build more. There's more services coming for them, so that they, even some of the lower, even Lambda within some of the features of it will be too low level for some, like the likes of Netlify and Vercel, or they abstract a lot about, you can run server-side code in the serverless function, which under the hood uses Lambda. But I have like a client who is semi-technical, who's like I wouldn't recommend him necessarily jumping straight into writing raw Lambda, whereas the likes of Vercel or Netlify is a really nice on-ramp for someone who is like building a web app and they need a little bit of server-side functionality to run some code on the server, say when the form is submitted. That's a really nice place to start.
Interesting. I feel like this is an excellent place to wrap up, but I feel like I really should mention the great workshops that Paul does. I took one of his serverless testing workshops. When was it? Last autumn or something? Last winter?
Yeah, it was November. It was November we did that. Yeah. I've
Exactly. I think it was really, really great. So just from personal experience, if you need serverless stuff, go talk to Paul, just because, not only because he knows what he's doing, but also because he's really great at teaching it. If people wanted to talk to you, Paul, where could they find you?
Yeah, sure. So my website is serverlessfirst.com. So if you go there on the homepage, I have a link to like a 5-part email course for helping people sort of, if you're interested in getting up to speed on serverless or moving your team over to it potentially, or finding the low hanging fruit that we mentioned in the episode. I cover those things in that email course. So that's serverlessfirst.com. And you can also get me on Twitter at Paul Swail, Swail. Yeah, and my other, like I do some consulting and my workshops that Luca mentioned, they're all on that website as well.
When's the next workshop going to be, by the way?
At the minute, I think we're talking late spring, possibly May this year. So yeah, I'm planning it next week. So hopefully, I'm hoping to make it. It's going to be a workshop, but I think I'm also going to have a course option. So you'll be able to take it totally on your own time. It's self-paced anyway with meetups, but there will also be a fully self-paced option at a lower price if anybody's interested.
Oh, nice. Okay. Paul, thank you so much for being here. This was a really interesting episode.
Yep, it was great. Thanks very much, Luca, for having me. Great fun chatting.
Thanks a lot.
Okay.
See you next time, Paul.
Cheers, man.
Bye-bye.
Bye-bye.